Quadratic formula and the discriminant. We can use the quadratic formula to solve any quadratic equation. That's why it's so powerful. The other solution methods we've talked about, factoring and solving with square roots to be specific, have their limitations. Completing the square would work anytime, but sometimes it gets really messy with fractions. Quadratic formula will work for any quadratic equation. So recall the quadratic formula. Let a, b, and c be real numbers such that a does not equal 0. The solutions of the quadratic equation ax squared plus bx plus c equals 0 are x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Important! The quadratic equation must always be in standard form before applying the quadratic formula. So let's take a look at an example. Solve using the quadratic formula. X squared plus 3x equals 2. First thing I notice is it's not in this all-important standard form. So I have to get it in standard form by subtracting the 2 to the other side. So x squared plus 3x minus 2 equals 0. I'm now in standard form and I can identify that a, the leading coefficient, is this unwritten 1, b equals 3, and the constant equals negative 2. So I substitute these values into the quadratic formula. X equals the opposite of b, so negative 3, plus or minus the square root of the b value squared, minus 4 times a times c, all over 2 times a. So then x will equal negative 3 plus or minus the square root of 9. Negative 4 times 1 would be negative 4, times the negative 2 would be positive 8, all divided by 2. Well, that's equal to negative 3 plus or minus the square root of 17 over 2. 17's prime, so we can't break it down any further than that. Our first solution would be negative 3 plus the square root of 17 over 2. Our second solution would be negative 3 minus the square root of 17 over 2. You do not have to find the decimal approximations for these. You can if you want. If you do, remember that you have to do the entire numerator first, then divide by 2. But in Honors Algebra 2, we'll be mainly focused on finding the exact simplified solution. Okay, so number 2, once again, we have to get it into standard form. So I need to subtract the 12x and add the 9 so that all my terms are together on one side. 25x squared minus 30x plus 9 equals 0. And now I can identify. A equals 25. B equals negative 30. And the constant equals 9. So we plug into the quadratic formula. The opposite of negative 30 would be 30 plus or minus the square root of negative 30 squared minus 4 times a times c, all divided by 2 times the a value. Let's move everything up a little so we have some more space. Okay, so x equals 30 plus or minus the square root of 900, 30 times 30, minus 900, 4 times 25 is 100, times 9 is 900, all divided by 50. So x equals 30 plus or minus the square root of 0 divided by 50. Well, that's really just 30 plus or minus 0, because the square root of 0 is 0, divided by 50. So it's really 30 divided by 50, because if we add or subtract 0, nothing will change, which can reduce down to 3/5. So in this quadratic equation, it only has one solution, which is x equals 3/5. Okay, so on example 3, we once again need to get it into standard form. I'm going to move my x squared and 4x to the other side because I want a positive leading coefficient, just so I don't have to deal with a negative in the denominator later on. So I'll have 0 equals x squared minus 4x plus 5. And we can identify that a equals 1, b equals -4, and the constant is 5. So we plug into the formula x equals the opposite of b, which will be +4, plus or minus the square root of -4 squared minus 4 times a times c all over 2 times the a value. So we have 4 plus or minus 16 minus 20 over 2. So x equals 4 plus or minus the square root of -4. So I know I'm going to have imaginary solutions divided by 2. So 4 plus or minus the square root of -1 times the square root of 4 over 2. So x equals 4 plus or minus 2i over 2. So we can reduce both fractions. So we'll have 2 plus or minus I as our solution. So in example 3, the solutions are imaginary. Example 4 is already in standard form, so I can go ahead and identify that a equals 1, b equals -6, and the constant equals 10. So x equals, well, the opposite of b is +6 plus or minus the square root of -6 squared minus 4 times a times c all over 2 times the a value. So x equals 6 plus or minus the square root of 36 minus 40 all over 2. So x equals 6 plus or minus square root of -4 over 2. X equals 6 plus or minus the square root of -1 times the square root of 4 over 2. So x equals 6 plus or minus 2i divided by 2, or x equals 3 plus or minus I. So once again, for example 4, we had imaginary solutions. So if you think back to the different solutions, so we've had 2 now with imaginary solutions. Example 2, we had 1 real solution, and on example 1, we had 2 real solutions. Let's take a look at what causes that. So a specific portion of the quadratic formula is what determines what type and number of solutions we get. And that special portion of the quadratic formula is the little piece that sits under the square root, b squared minus 4ac, and is known as the discriminant. So we need to learn the vocabulary term discriminant. When you read that, you need to understand that they are asking you to calculate b squared minus 4ac. And you're going to classify that, see if it's greater than 0. So if b squared minus 4ac comes out positive, then you're going to have two real solutions. So when you graph it, you'll have two x-intercepts. If b squared minus 4ac equals 0, there's one real solution. Meaning that the parabola sits on the x-axis. And if b squared minus 4ac is less than 0, so if it comes out negative, there's going to be two imaginary solutions. And so this would be a parabola that just does not ever touch the x-axis. Either concave up and it's above the x-axis, or concave down and it's below the x-axis. So let's apply the discriminant. For each of these examples, we will calculate the discriminant. So we will calculate the value of b squared minus 4ac, and then based upon that, we will list the number and type of solutions the equation has. We're not actually going to find the solutions, we're just going to classify them. So in example 5, the a value is the unwritten 1. So a equals 1, b equals negative 8, and c equals 17. So b squared, negative 8 squared, minus 4 times the a value times the c value. So that's 64 minus 4 times 7 is 28, so 68. So we get negative 4 for the value of our discriminant. Because it's less than 0, because it's a negative, that means I'm going to have two imaginary solutions. Example 6, again the a value is the unwritten 1, b equals negative 8, and your constant is 16. So b squared, so negative 8 squared, minus 4 times the a value times the c value. So 64 minus 64 equals 0. So because it equals 0, there will be one real solution. Example 7. Again, the a value is the unwritten 1. The b value equal negative 6. And the constant is equal to 8. So b squared, so negative 6 squared minus 4 times a times c, so 36 minus 32 equals 4. So because that's positive, there will be two real solutions. Example 8 needs a little prep work to get into standard form, so 9x squared plus 6x plus 1 equals 0, a equals 9, b equals 6, constant equals 1. So b squared minus 4 times a times c, so 36 minus 36 equals 0. So there will be one real solution. very important that you learn the vocabulary term discriminant. You cannot ask what that means on any assessment. You need to know what it means. The discriminant is the value under the square root. It's b squared minus 4ac. It does not include the square root. It is just the b squared minus 4ac. If it comes out positive, you know you have two real solutions, meaning that parabola has two x-intercepts. If the discriminant, b squared minus 4ac, comes out to be 0, you know it has one real solution. The parabola is sitting on the x-axis and only has one x-intercept. If the discriminant, b squared minus 4ac, is less than 0, if it's negative, then there will be two imaginary solutions, meaning that parabola does not touch the x-axis at any time. Okay, let's take a look at another application problem. A juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 40 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? Well, remember the formula we've been using now when we talk about dropping things. Height equals negative 16t squared plus force plus the initial height. So in this case, we're going to also add in velocity because the object's being launched or thrown. So we add in this middle term. They're saying it leaves the hand 4 feet above the ground, so that's going to be h sub 0, and the velocity is 40 feet per second. So height will equal negative 16t squared plus 40t plus 4. Okay, so our ending height, they're saying that it's caught at 3 feet. So I'm going to plug 3 in here. And so we're going to have to get everything on one side. So now we can identify A, B, and C. So A equals negative 16, B equals 40, and your constant is 1. So we apply the Pythagorean theorem. The opposite of B would be negative 40, plus or minus the square root of 40 squared, minus 4 times A times C, all divided by 2 times the A value. So negative 40 plus or minus the square root. Well, 4 times 4 is 16, and then be 2 zeros behind it. Plus, negative 4 times negative 16 gives us the plus sign, and 4 times 16 is 64 over negative 32. So x equals 40 plus or minus the square root of 1,664 over negative 32. So we can break down the 1,664. So 64 goes into 1,664. It goes in 26 times. So then we'll have 40 plus or minus 8 square roots of 26 over negative 32. And now I can reduce both fractions by 8. So x will equal negative, let's not go there quite yet. Let's just move it up so I have room. Okay. So we will have 5 plus or minus the square root of 26 over -4. So we have two answers. X equals 5 plus the square root of 26 over -4, or x equals 5 minus the square root of 26 over -4. We don't like to keep negatives in the denominator, so we should divide that up to the top, flip the signs on the top, so I'd have -5 minus the square root of 26 over 4, and -5 plus the square root of 26 over 4. Well, this answer is going to come out negative, so we're going to toss that one away because we don't want to go back in time, we want to go forward in time. For the other one, let's go ahead and find decimal approximation since we're talking about time. So if we take the square root of 26, subtract 5 from it, divide it by 4, get that x is approximately 0.02. So it doesn't take very long at all.